Okay, so here are a couple more examples with while I'm recording the writing of the formulas. Let's write a formula for write a formula for magnesium sulfate. Okay? Alright, so exactly like we did before. Magnesium is what? Mg. And sulfate. I just told you right up here, we just finished writing in class, that anything that ends in ate or ite is a polyatomic ion. And what that should tell me to do is have a little visit with my reference table. So I go looking for sulfate. And remember, it's not alphabetical, so search the whole list. I see it down here at the bottom. No. Sulfite is SO3 Sulfate is SO4 Be careful, because it does matter. It does matter the difference. The ate or the ite actually changes my polyatomic ion formula. So that says that sulfate is SO4 negative. So there I have my formula. Alright, what is magnesium's charge going to be? +2. I get that like we did before. I look at the periodic table. I see that it's in column 2. It means it's got 2 valence electrons. It's a metal. It's going to lose them because we know that metals lose electrons. Okay. I need to put these in the amount so that they add up to equal 0. They already do? Yes, they do. So do I need to add another Mg or another SO4? Nope. I'm done. I just need to write the final formula. Okay? When we write the final formulas, do we write the charges in it? No. So my final formula for this is going to be Mg SO4. Put what on the SO4? Okay, so if you're watching the video, he's asking, do I not put the charge on the SO4? Did I put any of the charges on the ones from before? And I can go back. Let's see. Here's ones we did in class. Remember this worksheet?
Go back to the ones you just did.
Okay, but look, did I put any charges here? In my final formulas, do I have any charges over here? No? Because they cancel out and they add up to 0? I used the charges to help me figure out how many I needed of each thing. But no. I don't put the charge up there in the final formula. Hey, do I put parentheses around the SO4? Because we had written a little note to ourselves up here about I must have parentheses around polyatomic ion if there's more than one. So why no parentheses right there? Because there's only one. And I told you, you cannot do it. We put it right here. You cannot put parentheses around polyatomic ion if only have one. It is not optional. I don't make up the rules, guys. I'm just teaching the conventions to you. You don't. Okay, what about ammonium hydroxide? Let's do one more. Okay, if I do ammonium hydroxide, okay, first thing first, did we learn ammonium as an element? Does that sound like one that you're familiar with? No? Okay, let's just say on a test that you can't remember. You're like something, nothing clicks in your head that I should look anywhere else for this. So I start looking through the periodic table and I can't find ammonium. If I can't find it over here in all of the elements, where else should I look? Okay, I can search down here at the inner transition metals, and I can search the transition elements and the rest of the families. I do not see anything called ammonium anywhere on this side of my reference table. Good, Alyssa. Flip it over to the polyatomic ion table. Hey, look, it's the first one. So my point is this. If you can't find something, because I've seen student after student do it, if you're looking through the periodic table and you just cannot find it, look at the polyatomic ion table, then go check there. Actually, as a matter of fact, there's less to check here, right? It'd almost be faster if you looked here first. So I see it right there. First thing, ammonium. Okay, so it says right there that it's NH4+. It is my only positive polyatomic ion. Okay, hydroxide. Well, I don't remember that mean old teacher making me memorize anything called hydroxide either. I may recognize that these things over here, they do end in IDE, right? These are the ones we changed the endings of. So if you look real fast, I don't have anything called like hydroxygen, or I have nothing that would have changed from hydro whatever to ide. So flip over again and look, and I see it right about in the middle. I find hydroxide. What is it? OH negative. I can definitely make an ionic compound out of 2 polyatomic ions. That is entirely possible. Okay, this one is going to lose 1. This one's going to gain 1. It's just like we did before. Do I need to add something else to it? Do I need to add 1 more hydroxide or 1 more ammonium? No? I'm already at 0? Then I simply write it down. No parentheses. No extra numbers. My final answer right there will be NH4OH. So I have my compound written correctly. I also have an explanation for you too. I told you that the best definition of an ionic compound would be that it was an anion and a cation added together. Well, this is why. I don't have a single metal in the mix, do I? Nope. Okay, let's work with naming these really quickly. If I go up here to writing the names, like let's say we're going to reverse this and like undo it. So if I gave you CaOH2, what I want you to be able to do is write the name of that. So here's my steps. I write them just like before. I write the name of the cation and the anion. There's absolutely no difference from any of my other ionic compound naming rules. There is a bit of a key here for you. I'll put it in red. If I see more than 2 elements, one of them is a polyatomic ion. So like up here, I see more than 2 elements. I see calcium, that's 1. I see oxygen, that's 2. And I see hydrogen, that's 3. I'm not talking about numbers, just simply the kinds. So as soon as I see that I've got 3 things, something has to be a polyatomic ion. So what is the name of the calcium ion? Do I change it? Just calcium. I call it calcium, so this is going to be calcium. Now, what a lot of students want to do is they want to name it individually. I'll see people writing down that this is calcium oxygen hydride. No. No. Remember, this is a group. I don't name the individual pieces. And it's not calcium oxide hydride or calcium oxygen hydrogen. This thing should have a name. Yeah, I just used the polyatomic ion table in reverse this time. I'm looking for the name instead of the symbol. So calcium hydroxide, several people are already saying. That is its name. I'm done. Okay. let's do another example. What if I have this formula, Fe2 So4? Same rules apply that I have already learned. So I need to name the cation and I need to name the anion. I see three things, right? I see iron, sulfur, oxygen. Most of your polyatomic ions will be the last two elements instead of the first two, because I only have one that's positive, that's NH4. So, bets are on that it's SO4, that's my polyatomic ion. Did the parentheses help me up here determine where the polyatomic was, too? Yeah. Okay, down here. Alright. If I remember from before, iron is where on the periodic table? It's a transition metal. And what do I remember about my transition metals? And I still do. I have not changed that. I gotta have the Roman numeral, the Roman number. It's gotta have a Roman numeral. So this is going to be iron something. And then go ahead and figure out what the other name is before we do the number. What's the SO4? Sulfate. Iron something sulfate. Okay, well, Zach's already saying 2. I am going to have to do a little bit of work. I mean, it's just like we did before, so you're getting some review of that too. I may have to write it out. So here's how I'm going to do it. I know that according to my formula, I have 2 irons, right? And I don't have parentheses, so I've got 1 sulfate. I don't know the charge of these. That's what I'm trying to figure out. But my periodic table or my polyatomic ion table tells me the charge of this one. What is it? I hear -2. Okay, I have 2 of these. Together, they have to cancel that out. So, together they have to add up to +2, right? So, +1, Andy says? The +2 has to be distributed across both of them. So that means each of them has to be a +1. So it is going to be iron 1 sulfate. You cannot just steal this 2 from down at the bottom and call it iron 2 because that's not right. So I'm going to have to do a little bit of work. Now, we have one more set of things to name. And the other set of things to name is our covalent compounds. So up on the top of my page, I'm putting naming covalent compounds. And if you take a second to stop and think about what we just did, were any of the things that I just wrote down covalent? We had MgNO3 we had CaOH2, Fe2 So4, Li2 CO3, MgSO4, and then we had NH4OH. Were any of those covalent? And I suspect a lot of people are going, I don't really know. Like, I didn't stop to think about it. You're going to have to. What do we say makes an ionic bond? Usually a metal and a non-metal. Usually. So, do you see metals in most of these? Iron, calcium, magnesium, lithium, magnesium again. Okay, as soon as I see a metal, guess what? It's not covalent. We've been drawing all kinds of covalent things. We've been drawing all these things on our paper. Did I have a single metal in any of these? HCN, CO, CH, ClO, SO, NO, SO, some more SOs, COs, HOs, NHs, CHs. Are any of those metals? What are all of those? Non-metals. Okay? So, if I have two non-metals together, they cannot be named by any of the rules that we currently know. I actually think this set is easier. Okay? So, don't forget that covalent compounds have all nonmetals. That's how I know I'm going to use this set of rules, is because there's nothing but nonmetals present. We use prefixes to do this. So here they are. For the number, if there's 1, we're going to use the prefix mono. 2 is di. 3 is tri. 4 is tetra. I know that quad means 4, and you use quad in places, but not here. We have to use tetra. 5, penta. 6 is going to be hexa. You use the prefix hex in geometry. You say like a hexagon. You can use the prefix sex, like sextuplets, but not in here. We're going to use the hex part. 7, we're going to use hepta, and it's one you may know that there's another prefix sept. Like you can say that someone has septuplets, which is 7, but we're going to use the hept prefix. 8 should be your good buddy oct. Octa is what we're going to say. 9 is nona. 10 is deca, yep. 11 is not commonly used, and honestly, I can't tell you what it is off the top of my head. 12 is sometimes used, and that's dodeca. Very good. We could go beyond that, but we're not going to.
13.
We're not going to go beyond
Do you know
12.
what it is?
I don't know what it is. Do you?
No.
No? Yeah. I looked up 11 one year, and I've already forgotten what it was. Obviously, I didn't write it down. Okay, here's the rules. Okay, here's the rules. All of the things we did usually had 2 elements. We're going to just name things with 2 elements, okay? So for the first element, we have some rules for the first element. You are going to write the name of the element with a prefix. Okay? The only exception here is don't use a prefix. Oops, I'm off the thing. Don't use a prefix if there's only one of the first element. I'll show you this in just a second. Don't use a prefix if there's only one of the first element. For my second element, always use a prefix and change the element name to end in IDE, just like we did for ionic things. So for the second element, always use a prefix and change the element's name to end in IDE. Okay. So there's one little tweak to go to the second element, or even I guess to the first one possibly, and I'll explain that in just a minute. Let's use those rules. So let's name a couple of things. Let's do I mean, you know this one. You already know the name of this one, but let's see how it follows the rules. CO2. You've had it in biology. What is that? Just tell me. You know what CO2 is? Carbon dioxide. Okay, let's see if it follows those rules. The first one says write the name of the element with the prefix. So the first element is carbon, and I said don't use a prefix if there's just one. So did I put the word or the prefix mono with carbon? Because there's only one. So I just call it carbon. The second one, I said always use a prefix. So how many oxygens are there? 2. So we use the prefix di. And then we use the oxygen just like I would have with the ionic thing, and I changed the ending to "ide." So oxygen becomes ox-ide. Put it together and I have dioxide. Carbon dioxide. Try another one. H2O. Okay. What's the name of the first element? Hydrogen. I don't change the ending. I'm going to write down over here hydrogen. Is there one of the first element or is there more than one? More than one. So may I use a prefix? I must. How many hydrogens? 2. So what prefix? So I'm going to put di on the front of it. Dihydrogen. Okay, so there's the first one. The second one, what's the name of that thing? Oxygen, but I'm going to change it to oxide. Okay, I need a prefix. I told you that you always have to put a prefix on the second one, regardless of how many. So what would go with it? There's only one. Mono? Okay, it sounds funny to say monoxide. So a lot of the things that go with oxygen lose a vowel. Like if you're putting something with oxygen, instead of saying monoxide, I'm just going to write down monoxide. So that is called dihydrogen monoxide. Do you recognize that as something else?
Water.
Water. But its chemical name is dihydrogen monoxide. Ask your teachers if you may go get a drink of dihydrogen monoxide and see if they know what you're talking about. I bet you most of them will. Okay, try another one. CCl4. Okay, do I need a prefix with the first one? No? Because there's only one. So I write down what? Carbon. I need a prefix with the second one. So what prefix am I going to use? There's 4. Tetra. And then what am I going to put after that? Chloride. Very good. Carbon tetrachloride. Let's try another one with oxygen and the dropping of the vowels just to make sure that we're good. What if I do N2O5? Will I use a prefix? Because there's more than one of the first ones. So what prefix? Di. Okay, what element? But I don't change the ending, do I? Not of the first one. Dinitrogen. What prefix? Penta. But it's going with oxygen, and it's harder to say if I say pentaoxide. So we drop the vowel on the prefix. So instead of penta, I'm going to write pent. Pentoxide. Oxygen is the only one that I drop a vowel with. Now, I don't drop every vowel. What if I actually had, what if I was going to name this one? What would I call the first one? Sulfur. What prefix goes with this? Tri. I'm not going to drop the I this time because that would make it called troxide, which is actually kind of weird to say. It is trioxide. So if you want this written down, like officially, because that's the only way that some of you write it down, is that I drop the vowel on the prefix with oxygen if the prefix ends in A or O, but keep the I's. So, did I drop the I off of dioxide? Because then that would be called carbon dioxide. Yeah, so it's carbon dioxide. I do drop the extra O, I do drop the extra, the A with oxygen, but with nothing else. Now, as far as writing the formulas of these, if given a name, it's usually pretty simple. So if we're going to do this in reverse, so for writing covalent formulas, when given the name, I just follow the prefixes. So how would I write out sulfur hexafluoride? What do I write for sulfur? S. Hexa.
6.
Fluoride.
FL.
So S, no, it's not FL.
Oh.
SF 6. The only thing that I find to be odd about it is that the prefix goes first, but the number goes last. So don't flip that around. Do not write S6F. Like that's, no. The prefix goes with the thing it's with in the formula. How would I write out nitrogen monoxide? Whether it exists or not, I'm just making stuff up. How do I write that? N monoxide. Oxide is O. How many? Mono. Just one. So I'm done. NO.
No.
Yeah. No. Okay. That's it. I mean, that's all of the writing and the naming. Basically, what we've done is we have tweaked the ionic rules so that you now understand how to incorporate these polyatomic ions we've been drawing. And we have added like a whole new set of rules. Now, what some student eventually is going to do, you watch, we wait and see who does it first, is they're going to use the prefixes that go with the covalent things with the ionic things. Someone will do it. Someone, if I have this formula right here, CaCl2, there will be somebody in here who will call that calcium dichloride. There's a way for me to know that I don't use prefixes here. It's based on the type of compound that it is. What type of compound is this? Ionic? And I know because what does it have at the very beginning? It has a metal. If it has a metal at the beginning of it, then it should have no prefixes, no mono, di, tri, tetra, penta, none, ever. Ever. I follow the first set of rules that I learned how to do. And then if I see something like this, NO2, what's the first element? Metal or non-metal? When it's a non-metal, prefix all the way. All the way home. Yeah, handsome. Which part? Right here? Huh? Right here? Okay, this part. Right there. Okay. About when to drop the vowel. Okay, so what we need to do now is we need to practice.